Hello, everyone. I'd like to welcome you to the Critical Materials Innovation Hub webinar series. This series is designed for and by CMI. I'm Cynthia Howell. I'm the Education Workforce Development Manager for CMI, and I'm going to be your moderator today. I'd like to tell you a little bit about the webinar. We are going to this webinar series, we're always looking for recommendations for topics. So we'd be delighted to hear from you if you have any additional ones. These webinars are hosted by Colorado School of Mines. This is a public webinar, and it's going to be available next week in the various places that you see, from a website to YouTube, all the things that we're familiar with. Questions and answers, that is going to happen at the end of the presentation. But in the meantime, we've got a Q&A segment, and if you would make sure that you tap onto that as soon as you have a question and write your question in, so it'll be queued up and we can flow directly to the questions. I'd like to take some time to introduce our presenter today. We have Adam Johnson from Principal Mineral. He's been a leader in the rare earth and critical materials industry for over 20 years. He's advised with the Department of Energy and co-authored many papers. He's currently the CEO of Principal Mineral and managing partner of Metis Endeavor. Again, he's had several roles across multiple companies such as MP Materials, Stardust Power, so on. And to round out his economics background, he has an MBA in finance from the Kellogg School of Management and Northwest University. And with all that experience, we're going to hear about it today, how it folds into his current position. And I don't want to take any more time. Adam, if you don't mind taking it away from here.
Hi, thank you for that wonderful introduction. Happy to be with you all today. So I'm going to go over navigating volatility in the critical minerals and materials market. Felt that that was a very apropos topic area, given sort of all of the things that are going on in the space today. And really sort of from an industry/operational and maybe even an investor standpoint is sort of where I'm thinking about it. There's certainly a lot to talk about in terms of how government can play a role, but that's not exactly where I'm sort of focused today. So I'm going to start with, I think, what is probably one of the most important areas, and sort of when we think about the bottom-up aspect of reducing risk through navigating these types of markets, is the human capital related to whichever part of the supply chain and whichever mineral area you're playing in. The people really matter. And that is something I've spent a lot of time over the last year and a half talking to a lot of different companies, a lot of folks who are participating in the space. That was almost genuinely ubiquitous. 100% of companies said that this was like a major topic area. We observe a lot of optionality within the human capital space, particularly in the United States, but I would say, generally in sort of Western markets, which is not just, competing for, human capital against other, say, rare earth producers or mineral producers. You're competing against, new manufacturing in semiconductors or data centers or energy and, everything in that related space. But then also, when you're thinking of new entrants from an employment standpoint, you're competing against, everything from, being TikTok influencers to, being options traders. And so it's a really tough industry to recruit people into. And it's been tough to, sort of maintain those capabilities, over suspended periods of time, given some of the, other macro volatility that can occur within, sort of specific companies or specific areas. And so this is something that's really important to pay initial attention to anytime sort of seeking efforts within a project. And I think we often focus too much on technology and process flow, and sort of capitalization, which is all really important and sort of fundamental, but simultaneously, when thinking about a project, it's almost natural to flow to those, and oftentimes human capital ends up being sort of the last thought under the premise that, oh, we can hire later for these roles, and it proves to be like pretty untrue. um, this is a macro headwind for every project. So in the United States, this is, I think, becoming more well understood that manufacturing jobs, there's going to be a huge glut of available talent. Um, and that will impact every company that is looking to build any sort of scaled or meaningfully scaled project um, in the near future. And so getting ahead of that early is really a key. The other thing that I have found in sort of what I've been in the projects that I've been involved with is that addressing that from square one actually improves the efficacy and competitiveness of the project itself, because you have those voices in the room earlier. There is cost to that, but there's cost to not having that also. Um, and this is not only when we're thinking about geologists or engineers. This is going to be true at sort of all layers of the, I guess we talk about capital stacks, I guess the human capital stack of what's required for delivering on a project in the critical minerals and materials space. So everything from welders to machinists to assemblers and sort of the like, there are major gaps in the availability of these types of skill sets. And when we're thinking about efficient operations and competing on a operating cost basis globally, which I think in the United States or even in any Western sort of country, um, is probably going to be the Achilles heel, is we can build these projects and we can deliver on a technology or a capability, but oftentimes it's not going to be globally competitive. Um, Getting those voices in early in terms of thinking about the delivery of the project itself to commissioning and into production can be meaningfully helpful, instead of relying on PhDs and engineers and EPCs only. Having the voices of people who have been there on the ground can be helpful, um, especially if they've been involved in similar projects. And there may even be justification for paying premiums for those types of voices early on, to contemplate the flow of operations earlier rather than sort of once you've got all of the equipment in the ground, now thinking about operations and sort of doing that once the dollars are spent. You may find that sort of you're actually pushing out cash flows in a way that is not productive to the overall sustainability of an operation. Um, and those types of voices can also contribute to the overall performance. So when thinking about um, the overall competitiveness of a project, cost is very important in a lot of cases. We're, not really, when you're thinking of critical minerals, not really commodities in the sense that they're, sort of readily available and uniform, but they're treated like commodities. And so, the ability to differentiate in terms of, how you're interfacing with clients and how you're delivering on the ground, in terms of everything from yields, but also in terms of, the safety and performance, and then also in terms of the knowledge of how an operation works throughout an organization so that you can communicate effectively and show competence to prospective customers and to customers that you have, as you go through the project launch and, delivery is pretty important. Um, and the more knowledge you have about the operation, the more credibility you can bring to those conversations in a broad set of ways. Um, so that's something that I always like to think about from the beginning, is sort of the human capital component. But, immediately you start looking at sort of structural issues when you think of navigating volatility in critical minerals and materials markets. Um, and one of the key structural issues um, that I think most mineral markets are going to have to address uh, in sort of the Western world is pockets of demand. And what we'll find is that oftentimes there are large pockets of demand for certain um, minerals and materials in certain forms or at certain stages, but at other stages that it's evolving. And therefore, you know, production at one stage or one area of the supply chain may be ahead of other areas. And this is, sort of, I'm taking for granted what I've is often assumed to be a linear pathway from, stage one, stage two, stage three, stage four of a project or a process flow, going from, say, like mine or end of life material to an end use application. But oftentimes there's sort of, ancillary or a lot of other granular stages within there that can substantively hinder the ability to actually reach those pockets of demand. Um, and so it is something that needs to be thought through um, pretty thoroughly from the beginning in terms of how the market dynamics work, and how you and your project or organization fit within sort of the supply component of those sort of market-based demands. And so um, I'll use rare earths as an example. Um, so we have, the didymium oxide forecast. And again, this is sort of a great example of, it's not a linear process. It's not necessarily stage one, stage two, stage three, stage four. Um, when we're thinking about rare earths, there's this sort of parallel reality of heavy rare earths and sort of ancillary sort of consumables and things like this that are, really important in terms of how those materials and products are available as the market evolves around the industry. And so everything from graphite anodes to, the, solvents and the ligands and the materials required for separation, as well as the heavy rare earths, those availabilities can impact sort of a project's ability to get from one step to the next. Um, so I'm going to sort of caveat this example with that reality, which is always important to be thinking about. But the example, I'm going to focus on the didymium sort of straight line process flow for simplicity. Um, so when we look at sort of the forecast of didymium, which, for those who are not familiar with that term, it just means that the two light magnetic rare earths, which is neodymium and praseodymium, combined as NdPr, which they often remain unseparated. And we see that sort of the United States is going to have meaningful production of that material, um, you know, through 2027. And so by 2027, 5,000 tons, 2026, 3,600. And this is, forecasted by Adamas. Um, and so um, you can see sort of, I did sort of simple math for us. Um, that 2027 number of 5,000, I just simply divided by 3 or 0.33, and you get to sort of a sort of simplistic way of thinking about how much magnet block that material can produce, um, depending on your efficiencies and so on. But that's sort of, 5,000 tons necessitates 15,000 tons of annual sintered magnet capacity. In the United States, if we want to keep that domestic, or in the Western world, if we want to sort of keep it in the Western world. And so that needs to exist in order to, provide the throughput that amount of didymium can produce. And we see in the US that sort of global, or within the context of the global forecast, is at about 1,000 tons. So, 1/15 of the way there. And I'm sure there are people on the, thinking about whether that's the accurate number or not, but we'll use that as sort of the baseline of truth for the purpose of this conversation. So, we'll have 1/15 of the magnet capacity that would enable the throughput of that didymium oxide. To speak nothing of metal, or alloy. And even if you count Europe, and Vietnam, and, you're still a third at best of the way there. And so that's sort of where you see these bottlenecks where, there is supply of the oxide coming, and the downstream has not sort of scaled up to match that, in a way that is meaningfully going to provide the demand requirement, for those producers, which, I think is something where, when we look at it more like the areas where, government can play a role, there is need to sort of look at this process flow holistically, and sort of that can be, a good way of dictating where support might be needed. But then you sort of look more broadly, at like the next step, which is, once you have those, advanced magnets that, go into the most important applications that we have, where are those end products being manufactured? And you see pretty clearly that China is sort of the lead manufacturer of those products that require, rare earth permanent magnets in the form of NdFeB sintered block. However, the next step down, which is who actually consumes those applications, it becomes much more split. And so there are pockets of demand but there's sort of a bridge to cross to get there. And it's in some cases multiple bridges across multiple companies because, as a magnet producer or as a metal and alloy producer or as an oxide producer, even if you were to integrate all or any portion of those, it becomes highly unlikely that you're going to then all of a sudden make the leap to producing iPhones or actuators for the F-35 or something. And so, there is this sort of complex market dynamic that needs to be evaluated about who are those counterparties that are here that are serving those pockets of demand, and who can companies in the critical minerals and materials supply chains collaborate with to achieve sustainable businesses that are not either overproducing and getting into that type of difficulty where they're waiting for the market to form around them, or you know, underproducing and sort of not fulfilling the need of those upstream suppliers or downstream demands. And so I think that is an area where, sort of market intelligence and real upfront effort and strategy is needed when you're thinking about how to de-risk a project. And doing that, taking a step back, further within the context of those ancillary or parallel supply chains that I mentioned earlier related to consumables and, equipment and, other inputs. When you're making NdFeB magnets, it's also not just heavy rare earths. It's, boron, and it's cobalt, and it's, other sort of additional materials that need to be sourced. And you have to do that in the context of, the scale and demand that you as a producer with whichever project you're pursuing can actually, put on the market. Or in some cases, like with cobalt, say if you're sprinkling in very little cobalt into a sintered magnet, are you able to source that, at those volumes if there was significant demand for cobalt in any given moment? And how are you sort of protecting yourself? And I would say also thinking about the capitalization of your project. Are you inventorying material correctly? Given that, your role in the industry is to sort of resolve the just-in-time problem and not fall victim to it. Are you thinking about working capital correctly and other questions? And so putting all of that demand into context, and then how does that affect your business so that you can deliver the outcome that you are promising to customers or to investors or to whomever, is sort of the next stage of where you want to take the information to, and then make it sort of specific to your circumstances and how that affects you. So lastly, sort of I sort of started at the sort of granular of, hiring, and getting ahead of everything from electricians to machinists to so on, and then then looked at sort of the specific demand related to the vertically integrated supply chain that whichever mineral you're looking at, you're a part of, and how those pockets of demand can impact your sustainability. Then I think going even a little bit further back to take a broader view, is sort of the market maturation and sort of timing overall. And there's always, the reason I sort of hit on this is there's always sort of this urgency, especially in times like we've had in the last few months, to sort of like race in and go after it and sort of that's all well and good. But a lot of capital that's going to be put to work now and in the last couple months and probably in the next year or whenever, um, the projects are not all going to be successful and sustainable. And the enthusiasm of raising capital and putting capital to work is great. Um, but putting that in context of where the market is relative to where the projects are and what others are doing, sometimes, it's better to sit on the sidelines and go and develop a technology or a capability that sort of can be ancillary or a investment thesis around the timing of the market such that you have a view on where and when you want to lean in given sort of the planning and sort of timing of it, and maybe it's best to stay small during a moment of time. And so I think it's really key. And we've seen this where companies have survived cycles by finding niche ways of sort of delivering, within the realities and constraints of the human capital they have and the actual capital they have and the demand signals that they've actually gotten from customers. And so putting that all in context around the market and how it's maturing, um, and sort of the realities of it. And so, you know, I've sort of simplified critical minerals and materials markets into sort of two segments. Here I refer to it as exchange traded and non-exchange traded. But it's sort of liquid hedgeable markets and then the non-liquid hedgeable markets. Uh, The non-liquid hedgeable ones tend to be the ones that are super important to high-end applications like defense and things like this. And then the exchange traded ones tend to be the ones that are going to be more broadly applicable to, energy infrastructure, things of that nature. And so each one is going to sort of carry different realities associated with it. And one reality that is really important that is not true in um, the non-publicly traded ones is that price isn't set competitively. In a macro scale where, there is a market that tells you how much, you know, uh, gallium is worth. There are sort of pockets of information that exist in say places like China. There are pockets of information that you can get from analysts that have sort of surveyed whatever information companies will share with you. But in reality, it's going to come down to direct negotiations on price. And there has to be sort of a view probably on both sides that being non-liquid markets, it's really going to be whatever is determined agreeable between the parties. Certainly in cases of like copper and nickel, that's going to be very different. And so that will impact your planning because in my observation, most mining companies are not historically designed to have those sort of like direct commercial negotiated efforts, for offtakes and sort of large commercial buyouts because they take a long time and historically they can sort of identify the price based on commodities. And so that will change how you have to structure your organization commercially to approach those markets differently. You will also in the non-exchange traded be more impacted by the influence of sort of global monopolies that sort of have a lot of influence in terms of the availability of those materials and how those prices are perceived, I wouldn't say set, but perceived based on, sort of like, frankly, intra-Chinese, sort of exchange prices. And so, when you look at that, those prices are going to be heavily influenced, and research is out there by the sort of trade and tax and tariff system. And so those factors, don't influence, you know, not on material that don't go through China. And so as a result, I would say that those are not necessarily competitively determined prices. Those are sort of heavily influenced by policy prices. And so you have to deal with the perception of price determination by your global monopoly competitor. And so I think that those are going to be significant headwinds that need to be navigated, and a strategy needs to be put in place pretty early in terms of how you're thinking about competition on that front, and sort of navigating that headwind. And when we look at the benefits of mature markets, you can say these are the benefits, but you can also say these are the things that you don't get when you have non-exchange traded markets. And I do think that, just as a caveat here, trading rare earths or gallium on the CME or London Metal Exchange is not as easy as creating a contract. There are contracts that exist for, say, lithium and cobalt that frankly have no liquidity. And that's in large part due to the fact that there's no underlying ability to take delivery on those contracts. And so as a result, they're not, they don't act as liquid markets to offset risk. And so the reality is we need to build the underlying volume of transactions, to start to form a market on top of that, and not vice versa, in order to be effective. And so there's no sort of silver bullet, oh, just go create a market for this. It doesn't work that way. So you can't just add these benefits that exist in, say, like a copper market to, or certainly like an oil market, to, these more esoteric markets in any simplistic way. And so when you're entering these markets, I would say this is like a eyes wide open reality. You will have to face, the lack of all of these market characteristics. So with that, happy to take questions, and go through, whatever, you all might be thinking about. I'm going to open the floor.
Adam, before we get going with questions, I don't see any queued in quite yet, but I'd like to thank you for a great presentation. And initially, I was looking at the title, Navigating Volatility in Critical Materials Markets, and you thoroughly opened up our eyes on the many, many factors that we need to take into consideration to be competitive in these markets, and in particular from workforce. Some of the individuals in the workplace that we need in the critical materials and minerals section that we wouldn't think of, such as machinists, such as, electricians, so on and so forth. And again, that's a lot there's demand for those individuals in many, many sectors. So it's quite competitive there. We work on workforce, so that's something that we like to learn more about, and where are those gaps. And then you go into the markets and you're talking about, making sure that you don't overproduce or underproduce. And we looked at the global picture with rare earths, great examples there. So with regard to where you're at and your business, how do you put that all into this is what we're looking at? Where are you? Where are your snags maybe that even some of the CMI folks can help with?
Well, I think that, I'm here in part because I'm very gratefully working with the CMI on, sort of a particular technology that is related to rare earth fluorides. So I think continue doing what CMI is doing and develop, incredible technologies and talent. I would say, um, one thing that companies can do and I think should do is work more closely with CMI. You have, great scientists, great engineers, great backgrounds of people. And so, I think that there are ways that, you know, through engaging proactively with CMI, companies can actually learn to train and sort of gather some of those, do some tech transfer there, and knowledge transfer there, in a really good way. And I would encourage companies to, sort of engage in those pockets of knowledge and do that not only at CMI, but anywhere you can find them.
Yeah.
Um, that is for sure. And so I would highly encourage that.
Thank you for that. And we have 3 questions queued up if you want to move into the Q&A section here.
Absolutely. So, first question is, do you think dynamic modeling of supply demand scenarios and geopolitical risk factors should be integrated to improve adaptability and price forecasting in critical minerals markets? Um, I think that there's, you know, efforts to do that. I think the challenge will still be, the lack of liquidity. Um, so, companies that are doing one-off commercial transactions that are indicative of Western, buyers and sellers are going to be hesitant to share that data with any third party. And even those that are, there's very few of them that are doing them and I would call it material scale, um, to justify sort of being indicative of a broader market price. There's sort of a bunch of small one-off like transactions that occur in different critical minerals and materials market. Those are going to be very difficult to trace. Um, so I think that modeling around supply and demand is important. I do think that for the tougher to, sort of trade publicly, like the more esoteric markets, I think what's really going to happen is a lot more volume, which means I think, the companies that are on this call and sort of that are in the space need to just continue to solve this on, a collaborative effort working with those in the supply chain that they know that are out there having all those conversations, having their own conversations, and then developing the teams that are capable of, engaging commercially with both the upstream and downstream, depending on who those where your company sits in the supply chain. So what do you think is, moving on to the next question, what do you think is the place of technological developments to solve some of these issues? Um, I think that when we're thinking about like a singular place to solve these technological issues, certainly, CMI is a good place to start. They spend a lot of time in the space. I think on a technology issue standpoint, I highly encourage people to engage with other companies because what I've observed is actually one of the biggest, um, uh, the one of the clearest realities that the market is not working in the United States and maybe in Western countries is that there's actually a bunch of great technologies and great technology companies out there that are so far either unable to raise the capital that's needed or unable to engage commercially, in a sufficient way, unable to do what I would call like commercial liftoff. And so what I would actually see that and I do see that as a great opportunity for somebody who's really willing to go and do the legwork in the industry, because there's actually a lot of incredible technology that's already been developed that companies already have out there. And the real key is going to be, how you can work with those companies, those individuals, those developers, to integrate them into a holistic process that is going to be competitive. Um, so next question, what is the balance between building supply chains for commercial versus defense? So I would say like the balance is going to be, you have an opportunity right now, I think, given the tone and tenor of the conversation, to look at defense in a more assertive way. The challenge will be, the dollars that are being put to work in order to get the returns needed by servicing only defense is likely going to be a problem. And so you need to certainly have a balanced view. Um, I think that commercial should be the ultimate end goal, in the sense that whether or not it's this moment in time that defense is sort of a key, center of attention on this, or 5 years from now when they may not be. Um, the primes are always going to drive towards the most competitive producers. And that's sort of why we find ourselves in the situation currently, is because historically they have driven to the most commercial and competitive producers. And so in the end, primes, outside of like these sort of idiosyncratic moments in time, are going to look a lot more like commercial. And they might just have higher requirements on purity or performance in one way or another. But in reality, the likelihood that you can look at them and say they're going to pay these premiums in perpetuity or things like that is probably, I would say, a mistake. So from an investment standpoint, what areas would you be most interested in right now? So the areas that I'm most interested in right now are related to the market problem. I've written papers on this. I've testified in front of the China Select Committee on this. I think that being a solution-oriented partner towards establishing and sort of furthering the development of markets, which could include sort of pricing transparency, or the sharing of data or so on, I think is valuable. I think that there's a lot of effort that's being put into that now, and I do think that that will have sustainable long-term outcomes. Um, because in the end, that's the only pathway to sort of, a more competitive critical minerals market broadly for some of these like more esoterics. And I would say even for, copper and the like, the market is not efficient, as is not as efficient as it could be, and there's a lot of breakages, and we've seen that with the tariff system, where there's prices set in Europe that are not the same as the U.S. anymore, and now there's huge surpluses of copper, refined copper, coming to the U.S. And so even in those publicly traded critical minerals markets, I'd say we're sort of at the beginning of the development there. The other area I do think is sort of in the midstream, in thinking about where to play, not only as sort of a primary producer, so like using rare earth magnets as an example. I sort of walked through, there's sort of these ancillary supply chains. So, heavy rare earths, but also other things like, developing, ligands that, are going to be more commercial or scalable, or, fluorides, I think are important, and sort of graphite anodes and things like that. I think thinking through sort of the broad spectrum of those is going to be important. I do think actually there's also an opportunity for equipment. When you think of an SEM or something like that for a lab, these are broadly usable machines that are not just for one critical mineral or another. And they are so much more expensive if I buy them in the United States than if I buy them in China. And so someone coming out and making a low cost SEM or optical, system for looking at microstructure, like these things are just way too expensive. In some cases they're hundreds of times more expensive, and they might have all the bells and whistles and be wonderful. Um, but sometimes you just need sort of the straight machine that does the thing without all the bells and whistles that you can buy for 1/100th of the price and sell 1,000 times more. So I think that all of these sort of ancillary areas are going to be pretty good opportunities also. Um, so another question. Early on, you mentioned that critical minerals are not commodities, but are treated as commodities. Were you referring to exchange, non-exchange traded markets or something different? I was referring to something different. So, when I think of like, I'll just keep using rare earth as an example. So like rare earth metal, like it's perceived as a commodity because it's, a mineral, it's a metal. And so we sort of treat it like a commodity, but in fact, there's um, you know, significant variance of purity. There's significant variance of like impurities. There's, all of these aspects of them that sort of can affect performance and so on. And in reality, what I've come across, and this is true, I was just talking to companies about yttrium, and you know, it's like they can get their yttrium from one or two producers because they produce it the way that is needed with a certain spec that's required with the certain types of impurities that are acceptable and not acceptable. And so in a lot of ways we want to simplify them as commodities, like, oh, the price of this is that and the price of this is that, but in reality they don't transact that way, and that's sort of what I was referring to. It seems like a vertical integration model needs to expand to include workforce development. Have you seen examples like this in the US or in other countries? um, I'm not sure I understand the question about vertically integrating into workforce development, but I do think that when you're planning a project, that is just a key component, right? Every project that I've seen from like stage one to planning or what have you, and these aren't the projects I've been involved with, talking about projects I've seen externally, like they all sort of start with like, you know, let's do the engineering, let's do, the technical, let's see how much it costs, can we get, the right capital structure? And very few, if any, talk about where we're going to get the people. And they do sort of a simple analysis like, oh, if we locate here, we'll have, this community college or this program, or we like them. But very few are actually active in like recruiting and sort of getting a technical leader who can be your like master electrician, or your, master machinist who can then be your advocate, who can go out and sort of, help you develop programs, with the local community colleges, and then sort of go and, um, train all the people you need, or something of that nature. I don't know if I've ever seen anyone approach it that way, and I do think that there is something to that needs to be contemplated and is worthwhile.
Adam, I want to thank you again for a great presentation, multi-factor of issues that definitely we all need to work together on to solve. And we thank you for what you're doing currently and how you're advising with DOE and working with CMI. And we look forward to continuing that and hoping to build some of these platforms that are needed to be successful. Anyway, there are no additional questions here, and perfect timing. We're just out of time. I would like to thank the audience for joining us today, and I want to remind you that we do a webinar series, so that we will be back again in August. And Adam, if you want to put up the last slide here for us. And we'll look forward to having you join us again in August. And you can find, again, a reminder, this recording is going to be available next week at aimslab.gov/CMI. We also are on our Critical Materials Innovation YouTube channel, so don't hesitate to use that to remember some of the facts that were presented here today. On August 19, we'll look forward to seeing you again, where we will hear from Ronald O'Malley, a professor and director of Peaslee Steel Manufacturing from Missouri S&T. Don't hesitate to send us your webinar topics and ideas so that we can continue this great series well into the future. Thank you again. Thank you for attending. We look forward to seeing you next month. Sorry.